The magic milk experiment is a simple science demo where soap makes food coloring move around in milk.
Do you know where to put the soap? Do you just put the soap on top?
No, that's what the Q-tips are.
Oh, do the Q-tips have the soap on it?
Yeah.
Oh. I think you have to take off the cap, buddy.
You know what I'm gonna do?
How many drops?
It doesn't matter.
I'm doing like one. I'll do two. We'll do two of each actually.
Do multiple colors in the same spot. Now do like 3 colors right in the middle.
Why is it purple?
I'll do like one more color. Right there.
You could do it. You could do that.
That's red. I think
Do like a blue.
Ooh,
Yeah.
where do you just did blue, right?
Yeah, but do it in all one spot. Okay, let's see it.
Wait, how do you swirl it?
I'm ready. You just tap it. It looks like piss. Go.
So theoretically, you should do the thing, right?
Imagine atoms are playing tug of war with a rope made of electrons. Electronegativity is how strongly an atom pulls on that rope. Some atoms pull very hard while others pull more weakly. Polarity is what happens when atoms with different electronegativities share electrons. If one atom pulls harder, electrons spend more time around that atom and it is more quote-unquote negative. So if some parts of a molecule are more negative than others, it's called polar. So what does this have to do with your experiment? Milk is made primarily of water, about 78% to be exact. Water, if you remember, is H2O. The oxygen in water is more negative and pulls electrons to itself. Therefore, water is a polar molecule. Since a water molecule is polar, putting a lot of them together allows them to make bonds because they have positive and negative parts. Also, polar molecules like to form bonds with other polar molecules. The same with non-polar molecules applies. Food coloring, like water, is polar, so it likes to bond with water. Soap has a polar and non-polar end, since half of it has uneven charge distribution and the other half has even charge distribution. So how does the soap make the food coloring move? There are two stages. In the first stage, the direct contact of the soap with the milk releases soap into it. This is what causes the initial spread of food coloring. During this stage, the polypi of the soap molecules are attracted to the water molecules and break the hydrogen bonds of the water molecules. This weakens the force between the water molecules, lowering what is known as surface tension. However, the soap only lowers the surface tension at one spot in the water where it touches the water. Other parts of the water still have high surface tension. There exists an effect called the Marangoni effect, in which liquids flow from areas of low surface tension to high surface tension. From the Marangoni effect, the milk with food coloring moves away from the area where the soap is. However, if you look closely, the food coloring continues to move even after the cotton swab with soap is released from the milk. This is the second stage of movement. This is due to the soap breaking down the fat. The soap's non-polar end is able to interact with the fats in the milk, allowing for it to be broken into smaller particles and forming small clusters of fat that move around, bumping into the food coloring molecules, pushing them even farther.